All right, the unit circle. Now, we've talked about the unit circle before, but we're going to go into a ton more detail on it. So as a reminder, the unit circle is a circle of radius 1 centered at the origin of the xy plane. You can see it right here. Because it's centered at the origin of the xy planes, we have that it intersects the x and y axes at -1 and 1. And here's the center right here at 0. We're going to start focusing in on this guy right here, on this point where the terminal side of an angle intersects the unit circle. So we have an angle, it has a terminal side, and we connect with the circle, the unit circle, at a certain point, x comma y. And we are going to give names to the x coordinate and the y coordinate of this point where a terminal side intersects the unit circle. For the x coordinate, we call that cosine of theta. Cosine of theta. And the way we write it is cos theta. Cosine of theta. That's this x right here is cosine theta. The other coordinate, the y coordinate, we call that sine of theta. Sine of theta. And we write it sin. We don't say sin, we say sine, sine of theta. So mathematically, when we're writing these, we're looking at these guys right here. That's how we typically write it. This guy right here, sine of theta. So these are just words we're giving, right? We know what coordinate points are. We're just calling the x coordinate of this very particular scenario cosine of theta, where theta is the angle, right, that is used to make that terminal side. And we call the y coordinate sine of theta. Now, because the equation of the unit circle is x squared plus y squared equals 1, which here's a review of the unit circle right here, or of circles in general, if you want to review it. And this is the equation of a circle with a radius r centered at h comma k. In our case, boom, we're at 0 comma 0. So h and k are both 0. And then the radius is 1. You end up with x squared plus y squared equals 1. That's the equation of this circle right here. Now, we just said that the x coordinate is cosine theta, and we said the y coordinate is sine theta. And if we replace those in this equation right here, instead of x, if we put cosine theta and then squared, plus instead of y, we put sine theta squared equal to 1, we get a very important trig identity. Now, I'm going to make a note that we typically write it like this. We write cosine, and we put the squared right there, cosine squared theta plus sine squared theta equal to 1. And I'll just make this note right here with any of these trig functions. If you have it squared, we rewrite it as the square on the inside. They mean the same thing. But this guy right here, soup's important. One of the, if not the most important trigonometric fact. Cosine squared plus sine squared equals 1. Or sine squared plus cosine squared equals 1. It's the same thing. It's going to be used over and over and over again. So let's start. For the following problems, you're given a coordinate point and the quadrant the point is located in. Find the exact value of x or y and not a decimal approximation. All right. So remember, with the coordinate plane, in quadrant 1, the x values are positive and the y values are positive. In quadrant 2, the x values are negative and the y values are positive, right? Because these are all negative x values. These are positive y values. Quadrant 3, x and y are negative. And then in quadrant 4, x is positive, y is negative. This is important because if we're going to be trying to find a missing value, which we have y missing right here, I need to know if y is supposed to be positive or negative, and that helps. So for this guy, we are in quadrant 3. Put this here, make it smaller. We're in quadrant 3, which is this guy here. In quadrant 3, y is negative, so I'm just going to make that note to myself. Y is negative in quadrant 3. All right. Then I'm going to use this equation of the unit circle, which is the same thing as this guy. We're going to do x squared plus y squared equals 1. X has already been given to us. X is negative 4/5. So we're going to do negative 4/5 squared plus y squared is equal to 1. That's going to be 16 over 25 plus y squared equal to 1. I'm going to subtract 16 over 25 off both sides. So 1 minus 16 over 25 is going to be 9 over 25. 9 over 25. I'm going to take the square root on both sides to get y by itself. When you take a square root, always remember to put a plus or minus. So y is equal, come on, pencil. There we go. Y is equal to plus or minus. Now, the square root of 9 over 25, this is the same thing as the square root of 9 over the square root of 25. Square root of 9 is 3. The square root of 25 is 5. So this will be plus or minus 3/5. We had just mentioned how y was negative in quadrant 3, so it has to be that negative 1. So we have that y is equal to negative 3/5. So what that's saying is, if I'm looking at this unit circle here, whatever the terminal side would be that would have an x value of negative 4/5, let's say it's like right here, right? And this x value is negative 4/5, right? Negative 4/5. That y value over here would have to be negative 3/5. Negative 3/5. And we can determine that, like I said, because we have the equation of the unit circle. Let's look at one more example here. We're going to be doing the same process. Duplicate, put this guy right here. This time we are given the y value, but not the x value. And we're in quadrant 4 this time. So quadrant 4, we're looking for the x value, and the x value is positive in quadrant 4. So x is positive in quadrant 4. So our final answer will be positive. We'll start again. X squared plus y squared is equal to 1. We know that y is negative square root of 11 over 4. So negative square root 11 divided by 4 is equal to 1. X squared plus, now the square root of negative 11, not the square root of negative 11, negative square root of 11 squared is going to be, right, negative square root 11 times negative square root 11. The negatives cancel, the square roots combine together to be 11. So this will be 11 over, and then 4 squared is 16. So squaring the numerator and squaring the denominator is equal to 1. I'm going to subtract 11/16 off both sides. I get x squared is equal to 1 minus 11 over 16, which is 5 over 16. We're taking square roots on both sides. X is equal to plus or minus. Now, this is going to be the square root of 5 over the square root of 16. We already determined earlier that x is positive in quadrant 4. So we're going to use the positive. And we'll simplify it. X is equal to square root of 5. And then the square root of 16 is 4. So square root 5 over 4. Oops, let's do that into blue. That's what I've done for all of them. Okay, so this is just the beginning of this unit circle. We're going to be doing a ton of stuff with the unit circle from here on out. And this thing right here is going to be incredibly important. You'll see it a lot in future videos, but I guess I'll see you then. All right. Have a good one. Bye.